delta change, I know the gain, I can calculate the delta change in heat input, right?
Yes.
Okay, and this input we multiply by cost of the input, we get the benefit. Okay,
Yes, correct.
fine. So this benefit is utilized to estimate that post APC this much benefit will come. Okay, but this shift, there are some certain assumption which we need to do, because we don't know when we switch on APC, we are estimating it will go to certain limit, but whether that limit will be actually reaching or not will depend on how other CVs would be quality, right? Temperature. If we have taken reflux ratio as a parameter to optimize, other CV where they will go. If they come earlier to the limit, this reduction may not be perfectly possible, right? So what we do, we assume, okay, there are some assumption which we need to make. Okay, first assumption is how much this standard deviation we can reduce, how much this variation we can reduce. Okay, standard deviation can be reduced. Okay, and second is how much this limit can be shifted. How much average can be shifted. Okay, fine. So this assumption both comes from the typical APC deployment cases. Okay, so there are this is what he was talking about. There are papers which tells that how much should be the optimization. Okay. So every places what we do, we take so processes before that. How do we calculate the delta F? So we calculate the standard deviation of R by F, existing standard deviation for the period which we have selected. Okay, we calculate the standard deviation. Okay, then what we do, we say that okay, this standard deviation can be reduced by 50%. Okay, we have taken 25